My name is Jason, and it's my privilege to welcome you to the Prairie Astronomy Club Astrophotography for Beginners class. Before we get started with the class, like I said, to kill a little bit of time here, I want to tell you a little bit about the Prairie Astronomy Club. I see some of you already grabbed some pamphlets. The Prairie Astronomy Club, as it sounds, is a club of people who think astronomy is pretty cool. It was formed in 1960, so in our 62nd year. We have meetings once a month, the last Tuesday of the month. Most of the time they're here in Hyde, though sometimes we will do them out at the Branch Stroke Observatory. During COVID, we did have them remotely via Zoom, and because of that, we still offer the ability to remote into the meetings even when they're live here in case you live far away or you can't make it that day. There are a lot of perks for being a PAC member, and I have a list. I'm going to try to go through them real quick, but they're really cool, and I want to make sure I hit them all. So first off, one of the great perks of being a PAC member is that you get access to our private dark sky observing site. That's a site that we pay for down near Cortland, Nebraska. It gets you away from the city lights. So twice a month, we try to have star parties. Lots of times they're down there in Cortland. Sometimes they will be up here at Hyde. Sometimes they'll be out at Branch Stroke Lake. Sometimes they'll be at someone's house if we're doing a lunar party or a solar party where the lights don't matter as much. Assuming the sky looks good, we won't go down there if the sky is bad. But with your PAC membership, Prairie Astronomy Club membership, you also get a subscription to the Night Sky Network. And what that is a coalition of amateur astronomy clubs from around the nation. So they have a website. You get access. You get a quarterly magazine mailed to your house called The Reflector. Has cool topics and articles about space. And then you also get access to the night sky events online. And those are things where you can remote in, and they'll have live events showing maybe around JPL, or one time I remember they showed what the living habitats would be for people who stayed long-term on the moon. So those are things that you don't get to experience unless you're a member. If the idea of a quarterly magazine excited you, I have to tell you about the fact that we have a newsletter for our club, and it's put together by Mark Domke. He's going to be one of the presenters tonight, but I love this newsletter. It's one of the best newsletters. I say newsletter, but it's more of a magazine in its own. So every month you get a new one. It's laid out great. You have topics about articles about space to read, history about the club. You get to find out things like, NASA's Perseverance rover highlights. That's one of the articles this month. We have an observing guide, so it tells you what you can see in the sky that month. So you get access to that with the membership as well. All of that wasn't enough. We have a lot more. So at our club meetings, we oftentimes have a live guest speaker, usually remotely, because since COVID, we've been able to reach out further and further. And so I just want to quickly go over the last 5 people we had because they're amazing. We had Dr. Emily Moravec, a Nebraska native. She told us about when she was out here when she was little. She's out on the deck looking through the telescopes here. Anyway, she's taken her passion for astronomy further and got a doctorate in it. And she gave a presentation called Chasing Radio Galaxies Across the Universe. So that's looking at radioactive galaxies in galactic clusters. And so she showed us how she uses the radio telescopes, pictures of that, and told us about what they do with the science and everything. We also had Evan Hilgeman, a mechanical engineer for JPL. And his presentation was called How I Drive a Rover on Mars. He is one of the few people that actually gets to drive the Perseverance rover around on Mars. And he gave us a live presentation. We also had Dave Nisley, a member of our club, and he gave us a presentation on telescope filters. And I bring that up because while it's great to see all these people doing really cool stuff, we also make sure we put some classes or some presentations in for things that are going to pertain to us normal people. And so this one happened to be about filters. Sometimes we do a class about telescopes, choosing things like that. So we do those. We also then had Jack Dunn, who ran the Mueller Planetarium at UNL for over 30 years. He gave us a presentation on innovations for planetariums. And then we had Christopher Mick, a NASA STEAM presenter, who gave us a presentation about Juno, the space probe flying around Jupiter and the moons. And again, you get to see lots of cool photos. You get to ask them questions. So 5 times in a row, we had wonderful live presenters. Additionally, you get help with observing programs. If you're not familiar with what an observing program is, it's going out and looking at certain things and checking them off a list through a telescope, through a camera, whatever. You get a certificate for saying that you completed it. We have people here that will help you fill out the paperwork and get that certificate of completion. If all of this sounds like too much, hard place to start, we do also have a mentorship program. And so if you're not comfortable, when you join the club, we ask you if you'd like to be part of the mentorship program. We find out what kind of equipment you have. We try to find you someone more experienced that we can pair you up with so you can ask questions, or at least you have a friendly face at the star parties or here at the meetings when you come until you get more comfortable with things. And lastly, we do astronomy outings and public events. So we do volunteer. We volunteer out here at the deck sometimes. We volunteer for like Girl Scouts. Sometimes, like I said, we do private parties for ourselves. For instance, coming up this summer, we're going to do one for the James Webb Telescope, which is the new telescope in space that's replacing Hubble. They're going to be releasing their first images, and we're going to have a party for the city of Lincoln for the public to come and attend. We also recently, 2 weeks ago, went out to Lord's Ranch near Valentine. If you've never been to Valentine, the skies are amazingly dark. So some of the club members just went up there for a private thing. We rented out some cabins. We got rained out 3 out of the 4 nights, but we still had a good time. And then we're also big participants in the Nebraska Star Party, and that's also up at Valentine. I think about a week-long event. Astronomers from all across the country come and use the dark sky that is near Valentine. So, if all of that sounds great, it's really simple to join. It's just $30 for a year for an individual. If you want your whole family to join, it's only $35, so $5 extra bucks. It doesn't matter if you're a 2-person family or a 10-person family. And then if you're a student or have a student that you think would want to join, elementary school up to college, it's just $10 for a student, but we do ask that they volunteer. So that could be out here on Saturday nights during the public viewing parties, other volunteer options. So we have John back there. He's our treasurer, and if you want to sign up tonight, he can help you with that. Otherwise, I see, like I said, you have some pamphlets that you can pick up and think about some more. That's my spiel. I think we have everyone that's going to show up, so we'll get into the class. Tonight we have the Astrophotography for Beginners. We're going to go over a wide range of topics that's going to give you a hint at some of the options and let you then hopefully find more things to spark your interest and continue going on with your interest in astrophotography. We're definitely open to more questions. We'll stick around for a while afterwards and answer things. We can talk about some of these things that are laying around here or what we use to do our astrophotography. So tonight we have 3 presenters. Mark Domke, who I mentioned, he is our resident historian of the club and the writer of the newsletter, and he has compiled and edited the first 50 years of the Nebraska, or the Prairie Astronomy Club. He's put a book together. And then we also have Brett Bowler, and he is the, my notes didn't update. Anyway, he has the Bowler Civil Observatory out at Branched Oak Lake Observatory. And then my name is Jason O'Flaherty, and I'm the vice president of the club this year. With all that said, I'll turn it over to Mark.
So, welcome. First, I wanted to kind of get an idea of, for visitors, are you avid photographers? Have you done a lot of photography in general? Are you familiar with some of the ins and outs of things like exposure and light and lenses? I kind of cover some of the basics of that and wanted to check and see kind of where you're at.
I'm a beginner on all of it. So.
Okay. So these are topics that we're going to cover, as was mentioned in the description, and also we're recording this, and we're going to put it online along with some links to some of the sites that we'll talk about and other things, so you'll have it for reference later. So we realize that this could be information overload, and we're going to pack a lot of stuff in, so don't worry about it. You can always go back and look at it later and ask us questions later, and also, again, as Jason said, you can always come to our club meetings. They're actually open. You don't have to be a member to come and can visit us, so please do. Next meeting is on the 31st at 7:30 right here. So basic topics that we're going to cover: a little bit of wide angle, just using a regular lens, taking pictures of the Milky Way, some planetary, solar, and lunar, and then some deep sky using a telescope or a longer lens. And I'm going to kind of breeze through this all fairly quickly, and we're going to trade off. Jason, we'll need the microphone for Brett too. So did you get it? Oh,
Yep, I got it.
Okay. Anyway, we've got also some examples here of a smartphone mount, and then I've got a star tracker here, and Brett brought his big heavy-duty
My travel
equatorial.
scope.
Yeah. So basically, you can do a lot with the smartphone. The lenses are getting really good these days, and some of the cameras advertise really low light, night photography. So you probably already have one. The downsides are that the lens is fixed. They generally have more noise because the sensor is very small, and at night they're not going to perform as well as a regular camera. They're very hard to hold steady, and there are some add-on gadgets to mount them on a tripod or add lenses, so that helps. And often you can't adjust the exposure or go into manual mode as much as you'd like. Point and shoot, kind of a thing of the past now, but they're cheap. They have some of the same characteristics as a smartphone, but if you've got one and it performs well, you give it a try. DSLRs, this is a Panasonic Lumix. That's my favorite now. You've got interchangeable lenses, a much better sensor, generally lower noise. The bad parts are they can be much more expensive, and for those, when you get into it a lot further, one of the things that is sometimes nice to have is infrared photography, and there's a filter in most cameras that will block the infrared light. You can buy specialty cameras that have that removed, or some cameras you can have it taken out, but that's a feature that more advanced photographers sometimes like to have, so that's another consideration and an option. And then on the high end, and we're not really going to cover here, is dedicated astrophotography cameras, and these things are custom built, and they don't have the infrared filter. They are generally much more sensitive and good for low noise. They can be very expensive though, and also in order to keep the noise level down, they're actively cooled. So there's a Peltier device in there that you want to bring the temperature down to like freezing in order to get the best possible image with the lowest noise. Types of mounts, depending on or what you can do with the mount, is again with a smartphone. If you can get a camera or an adapter for a camera, something like this, then you can shoot through the lens, the eyepiece. Results may vary, and it can be really hard to get that aligned, and sometimes can vibrate a lot. But I've seen some really nice photos taken with those. You can also, things like the moon and sometimes, planets will work well with a telescope. The star tracker type of mount is what I've got here. This is the MYOPS, and I'll talk about that later. And some of those are, they range from in the $100 to $200 range. And they're very handy because they have a motor drive and it will track the stars. They're really easy to set up, and they give you a lot more flexibility. Even if you just extending your exposure from 30 seconds up to a minute or two, even it doesn't have to be tight, really well aligned. You can still do a lot better with that over just a plain tripod. And then of course, with a stationary tripod, you can do time lapses, Milky Way photography, short duration things that don't require guiding. And then of course with the telescope, you can end up with a lot of gear to adapt your, hang your camera lens on there. But that gives you a lot of capability, but also a lot more equipment to set up and, a lot more complexity to deal with. Briefly, image sensors. Used to be we had film, and now we've got sensors to worry about, and it can be a complex subject. Size of the sensor and the sensitivity and the noise coming out of it. Basically, the thermal noise that you'll see even in daylight photos if you zoom in on it. That is caused by basically it's random from heat from the camera itself, and it's infrared energy that is increasing the the voltage level in each of those pixels. And that shows up as that kind of mottled look. And what you want to do is reduce that as much as possible. Well, one of the ways to do that is pixel size. The larger the cell size in micrometers, the more light you can collect in each pixel, and therefore more light and less noise. The higher pixel count, 20 megapixel sensor versus 12, if the sensor size is the same, the pixels are smaller and they're not going to be as good for night photography. So in this case, bigger pixels are better for low light. And again, it also has to do with, you're not going to get as good a resolution either. So it's always trade-offs. Moving on, basics of exposure. So with any camera, you've got these sort of three parts to it. You've got the aperture, which is, the size of your lens, your optics. Bigger is always better. You're getting more light. On the other side, you've got ISO, which in the film days, that was the film speed, and now is basically just used to apply to the sensitivity of the sensor. The thing about ISO is, let's say if your camera base is 100 ISO, when you take a picture and you bump the ISO up to 800, you're not really gaining sensitivity. All it's doing is every pixel, or the number value that comes out of each cell for the brightness level, all they're doing is multiplying. So if you've got ISO 400, they're just taking that value and multiplying by 4, including the noise. So everything goes up and you don't really gain that much. Of course, shutter speed, sharpness, you lose sharpness if your object is moving at all. So somewhere in the middle of this, depending on your photo, is where you want to be, and that is something you just kind of have to learn by experience. The other part of this is the F number. So you've got the lower F number is better because you're getting more light, but at the same time, depending on the quality of your optics, on the low end, you might get things like spherical aberration might show up. There are defects in the lens. It may not be focused the same across the whole field. And you might, with bright objects, you might see purple fringes and things like that. So the advantage of stopping it down a few stops will sometimes mitigate some of that effect, but also then it's not going to be as fast and you've got to expose longer. So the cool thing about the way they set this up, 100 years ago or more, was that for every f-stop, it's a doubling. So you're doubling or going factor 2 either direction, and so like 1 second at f4 is the same as 4 seconds at f16. So as you step up and down in exposure and aperture, and ISO works the same way. It all balances out, so you can get the same effect. Well, and by doing that, again, you're doing a trade-off. Okay, you've got a shorter exposure, so there's going to be less motion or less blurring, but at the same time, you're going to have to open up the lens to do that, so then your optics has to be good. So it's all these trade-offs. So again, this is an example of coma. I've got another slide that shows that better, and just kind of the trade-offs over here of there's a noisy image of the moon. So yeah, here's an example of coma. So you've got in the center a fairly nice galaxy, and all these really bright stars out here have blurred out like this, and that's because the light coming in at an angle off of the center of the farther out you get from the center of the lens, it's doing this. It's focusing the light at different places, and it creates a little kind of a stretched effect. So that is a characteristic of a lens at wide open, and the only solution to that problem is stop it down or buy more expensive lenses. RAW versus JPEG. Always shoot RAW unless your camera can't. JPEG is sort of like if you have, in the old days, you had a negative and you had the print. Once you print it, you've baked in a lot of, well, whatever you've got, it's just there. That's all you've got to work with. JPEG is a lossy compression algorithm. It's designed to show what the human eye can see, and so all of that stuff that's dark, all the bottom end of your image, it just throws it away. Well, then if you go in to edit it in Photoshop and you try to crank up the dark areas, it's going to be all noise. whereas RAW retains that information, so you can pull that back. And here's an example of a JPEG version and the RAW processed version, and look all the noise left over in that image that can't do anything about. And down here kind of shows the effect of that with the algorithms. It will throw away the bottom part of this and preserve the bright areas. So there's just no other way you can fix that. Guided versus unguided. Again, the tracker I have right here is this one. So, and I built this little bracket here because when I first tried using this, I just put on a regular tripod head, but there's too much weight hanging out over the tripod and it wasn't stable. So by extending it over a little bit and lining up the center of gravity, it works a lot better. Anyway, so this is just a regular tripod head, ball head, and put any camera on there. And then this guy is controlled by a phone app. And all you have to do is a kind of a rough alignment north and get the right latitude, which I have a little finder scope that matches up with the where it's pointing, so I can just get it. If you're within a degree or two of Polaris, is good enough for 2 or 3 minute exposures. If you're going for a really long exposure, then you need to fine tune that a little more. So yeah, down here we have this is a sample of a poorly focused, unguided shot. That's, if you get more than about 30 seconds to a minute, that's what's going to happen to it. In some cases, unguided, you could do nice star trails, and star trails are a nice starting place. We all do those. They're kind of fun, especially if you get a really long exposure. Brett has one that we'll show you later. This is my German equatorial mount with my short tube refractor on it, and I use that. It's about 500 millimeters. I use it like a telephoto lens, and it's a really handy size. And then this is a fancier Celestron Schmidt-Cassegrain, which is in the $1,500 range, depending on how big you go. And so you said
not just a camera, that's a telescope.
the whole telescope, yeah. And so that has a fork mount that so it gets polar aligned, and then you can hang a camera on top of the scope or through the eyepiece. One note about stabilization. A lot of cameras have in-body or lens stabilization. Probably want to turn that off, because what happens is it sees stars moving if you're not tracking, and it tries to compensate for that. So it can actually make things worse. So just be aware of that. And another issue is camera shake. When you're shooting, some of you have done this, you probably know, you set a timer or use a shutter release so that you don't touch the camera, because any vibration, it's going to just sit there and ring for a few seconds, and that's going to blur up your photo. Okay, we'll put links up to some of this. These are some of my favorite places for gear. Ken Rockwell has great reviews of lenses and just about anything you would want to know. Cloudy Nights is where astronomers, is a good place to buy and sell used gear. KEH is another favorite of mine for buying used equipment. They're very reliable, reputable. They test everything out, and I've gotten some really good deals through them. Off onto a few more subjects. Light pollution. The best thing to do is just get as far away from city lights as you can. There are filters. Some of them work, some of them don't. Depends on the street lights and the color of the light and all that, but it's just best to stay away from them. And then Jason will talk about stacking photos a little bit later and how you can reduce noise. In fact, here we are.
Hello, I'm back. So I took this class 2 years ago when these gentlemen gave it in February, just before COVID hit. And I signed up for the Prairie Astronomy Club that same night because I thought it was cool. And I set out to start my astrophotography adventures. And one thing that, despite all the information they gave, they were missing information about stacking. And that was something that I kind of struggled with. So I was like, when we do this again, we're going to put stacking in. So stacking images is the process of combining multiple images of the same object into a stack using software. Improves the image in two ways because it reduces the noise. So talking about like the ISO that he was talking about, or you might have a hot pixel that's glowing more, or even it can get rid of, if something flies in the middle of it, it can help get rid of that. And it stacks it up and averages out the images, like the dark areas. It also compounds the amount of time captured. I'll show you in a little bit an image that I did that with. And what that does is, so as Mark was talking about, you can leave your shutter open for 60 seconds, or you can take 60 1-second photos and stack them on top of each other. And that more or less equates to then a 60-second exposure. And so that helps you. It's a good tool if you need more light and want to have a cleaner image. So go ahead and go to the next slide. So I took 2 images here, a single image, it's 100 seconds of exposure of the Andromeda galaxy, I believe, and then 15 stacked images. So that equals, when you add them up, 25 minutes of combined exposure. So unedited, they look more or less the same. But as we start to edit them, the first thing I do when I edit this is I increase the exposure to bring out some of the light. And so you can already see in the single image all of that grain and noise coming through compared to the stacked image, which I've used software to do the stacking. So I'm editing what the software has spit out. You can see that all of the grain has been averaged out. Go to the next one. So then I go in there and I use noise reduction in Photoshop to get rid of the grain a little bit more. So again, noise reduction is still blotchy in the single image, and we get a much cleaner picture in that stacked image. And then finally, I did a fully edited version, and the big difference is you get a lot more detail in the clouds, and then you can see up there in the single image how the banding from the light is very noticeable. It's not a smooth gradient in that single image compared to the stacked image. So that's all things that, you can still take a 60-second photo, like these were 100 seconds. You can still take long photos, but if you stack them on top of each other, it can help mitigate some of the other things that can happen. So go ahead to go to the next slide. So these are 2 photos I took and stacked images. So this is the Whirlpool Galaxy and the Cigar Galaxy, 2 Messier objects in the same field of view. And you can see that I stacked 40 images for that, and then using software, and then went into Photoshop and just brought out all of the detail. And this one over here I think is great because that is with a wide angle lens. You don't need to have a star tracker, you don't need to have a telephoto lens, you can still go out and do awesome stuff. And so I took a whole bunch of 83 images at 15 seconds, so very short, not enough time for the stars to have moved in my field of view. I didn't have any star trails, and so but I was able to bring out all of the light by stacking them up. And you can go to the next slide. So anyway, here's a list of some of the star stacking software. There are a number of free ones, especially if you have Windows. I use a Mac, so I use the Starry Sky Stacker, and that I think it's like 20 bucks. But if you're going to get into this, it would be a wonderful topic for a future class, but there are also YouTube videos out there that kind of teach you how to use the software as well. But once you figure it out, it's pretty simple. You take a whole bunch of photos, and then you put your lens cap on and take some more photos without letting your camera cool down. And what that does is take black images, but the grain, the heat from your sensor that's been going on is also captured, and the software will then subtract those hot sensors out. So when you go to use star stacking software, you say, these are all my light images, and here's some dark images, and it'll say, oh, I want to take all that noise out from the dark images and help give you the cleaner image. So that was a pretty deep dive thing, but like I said, there's lots of tutorials on how to use that software.
Yeah, the other advantage of that is if you're guiding, or if you don't have a precision guider or tracker, that if you do a lot of short exposures, then if you're off a little bit, you start seeing star trails, you can minimize that effect and just take lots of short ones, and you won't have the stars moving on you, and then stack those. So, wide field. Do you want to?
Yeah, I'll take this. So there's wide field, planetary, and deep sky. This is probably the easiest one to get into right away. It doesn't take a lot of stuff. Of course, like up there, you know, it's short 1 to 30 seconds. This was a little bit longer, and it was piggybacked to make it we're trying a different concept to do different things. But essentially, you can get shots like this just with a camera on a tripod if you keep about 30 seconds.
And also, this shot is in that. We'll get to that later, but that's a little piece of that one.
Another easy thing you can do is just camera on a tripod, set it down, don't move it for all night. So I had the opportunity to go to Egypt, and that was from our balcony. So, I mean, not stable ground, you're on a balcony, it shakes, but I set it up, we had a pretty clear night, and I just let it go for about 8 hours. And then there's a free software called Starry Night. No, what is it? Star Trails. Just Star Trails. It's free. You load all your images in there. You hit a button, and it puts it all in there like that. Of course, then I edited it with Photoshop and stuff. But essentially, an unedited version of this is 1 click away with a tripod.
And
I think this is your picture.
yeah, that's one of mine. That was taken with my previous camera, the Lumix GX8 1600 ISO, 12 millimeter wide angle, 60 seconds, not guided. So that's, like I said, about the limit of what you can do with a wide angle lens without guiding.
Was this in town or?
Oh, sorry, that was out at Nebraska Star Party out at Valentine.
Very dark skies.
Yeah. And this is the kind of thing that I like to do, is have, something in the foreground, landscape photography, and then, at dawn or dusk, you can bring in some color and get some nice effects with the clouds and still get stars in there. And this is another one of my favorites. This was taken on the Big Island, and I didn't have my tripod with me. However, with the in-body stabilization and the lens stabilization, if you hold really still for 1.5 seconds or more, and take, about 30 or 40 of these, you might get one that works. That's not shaky, but it's actually doable. So that was kind of fun. And that's a Micro Four Thirds sensor. So let's see, and also dawn and dusk shots. You can still, if you get there at the right time, just before the color starts coming in the morning, you can get some nice shots. And also another Hawaii shot. The one on the left from a moderately dark location with spotlight pointing at the palm, unfortunately. The one on the right, though, was taken in a well-lit parking lot in town. It's just that in Hawaii, they have light restrictions, and they use the special lights that don't interfere with the telescopes on the mountains. So that helps to some extent. But still, there was a fair amount of light there. But yeah. And this one was taken out at Branched Oak Observatory. That's down there is Brett's observatory. And this, of course, you can see the Lincoln sky glow over here, but that was 13 seconds, ISO 1600. So, not too bad. Get a little airplane in there. And this is another shot I did out at the Nebraska Star Party of Andromeda Galaxy wide-angle lens, a 50 millimeter lens. That was on a Nikon D600, which is a 24 megapixel older camera. So it's not quite as sensitive or as good as what I've got now, but still, I still have it. And it's a good camera. And then more.
So this is another just tripod shot. It was during a lunar eclipse. And set it up, and I had my camera set up on my telescope, but I had another one just set up in the background. Started it going, and it took a shot like every minute or every 2-3 minutes for 20 seconds, and then put into that starry night, or I don't know why I'm thinking Star Trails, and let it stack, and then you can see the progression of it. And this was right at sunrise. Next.
There we go. Do you want to go ahead?
Well, planetary, that's something that if you have a telescope, you can kind of hold up a camera to the telescope, or you can get a solid tripod and image that way. They're bright enough, so like the moon in planets, you don't have to have this long exposure. Usually they're sub-second exposures. Full moon could be 200th of you almost handheld them, but depending on how much telephoto lens you got, it could be shaky. Like it says, the moon's an easy target, and the prime focus is just a camera with a lens on it.
Yeah, it's the difference between using the telescope as you would a telephoto lens, and the other approach is eyepiece projection, and that's like when you were using this lens to look through the eyepiece of a telescope. So that magnifies your image. So
there's also other, you can image the sun, but you have to have special filters. Don't ever look through the camera eyepiece or anything at the sun, or it's going to ruin your camera and your eyes.
it depends on the camera. Short exposures, I've done many, even video of sunsets, but just don't let it sit there and burn in. Literally, it will.
And sunset's a little different too when it's
Yeah.
on the horizon, because you have so much more air that you're
Right.
going through. If you're pointing straight up, that's
Not good. And also the moon, well, I'll let you go ahead.
so the best time to image the moon is not when it's fully illuminated, because it's shining straight at it, or from our perception, the light's coming straight onto the moon. So you want to, like, quarter moon, or when it's just a thin sliver, you're going to get a lot more of the details popping up. So like this mountain range right here, like the shadow's about here, but that's sticking up into the shadow, so you get that depth of it a little bit more.
And yeah, the one on the right is one of mine. Again, I kind of like shooting in twilight because you can have bring some color into the sky and give it more depth. Actually, this is one of mine. So I did the moon and Jupiter. So in one shot with this is an 80 millimeter prime focus through a scope. So you get the moon, and that's actually Jupiter real size, and then the box, this just is a blow up that I added to show that you can actually see the moons. That's in the shot. It's not, you blow it up big, you can see that it's actually in the image. The problem there is that the moons of Jupiter are so dim compared to Jupiter that you're never going to be able to get both of them exposed properly at the same time. And one of Brett's.
This was out at Branched Oak Observatory. We were out there, and it's the moon and Mars. The little dot down there. I'm trying to think was this a screen grab off a video, or was this an actual?
I don't know where it came. You sent it to me. Okay. I don't know where.
I know that one time it was Brian and me and Michael Simerson were out there, and we were watching it go go behind the moon. So. And
I think those are yours too.
This was some of my first images. This is probably 10 to 14 years ago, and this is through a Schmidt-Cassegrain telescope. And I think these are single exposures of Jupiter and Saturn, but you can get pretty reasonable one-shot images on Planetary. And then if you would do the stacking thing with different stacking programs, you can get a lot clearer images.
Yeah, that's a topic we didn't touch on. It's more of an advanced thing, but with the stacking, like Registax, it has the ability, like if you shoot video of a planet and you can see the atmosphere messing with it, all the turbulence, what it'll do is every few frames you might get a point where the atmosphere just goes completely clear and it kind of freezes out and you get a nice sharp image. But those are very, only 1 out of 100 shots maybe, or per second of video. Well, the software will go through and throw away all the fuzzy ones and pick out all the good ones and stack those, and you can get some amazingly sharp images just off of video.
The other good thing with the video is you're probably shooting at 24 to 30 frames a second. So
yeah.
1 minute in, you have thousands of images to choose from. And so, it don't take very long to shoot a few minutes or an hour and get hundreds of thousands of pictures to go through.
And yeah, we have all this incredible software now that can do this stuff for you. It used to take, well, almost as impossible to do before, just the last 10 or 15 years. This is one of my projects from way back, and I someday I should repeat this just to, with new technology, but Pluto is a tough one because most small telescopes, you can't even see Pluto. You need, what, minimum of about 10 inches or so to see it in good condition. So anyway, what you do is you point where you think it is, and in fact, this case, I took a whole bunch of shots of the whole area with a high magnification eyepiece, and through the, actually that was I think that was eyepiece projection. And then you sit down and look at your star chart and try and match up a pattern of stars to figure out what it is you're looking at. And then you look for the one little star that has moved over from one night to the next. And then by comparing that to the star chart, you can say, that's Pluto. So it's a bit of a challenge, but it's kind of fun. Solar eclipses.
So this was a solar eclipse. I think I was up around Sioux City with school, and it was right at sunset. It was a partial, but it was right on the horizon. So there was no solar filter on this shot, but it was like ISO 100, stepped all the way down, 1/4000th of a second, and it was still, you can see it was blowing out the image.
And this is one of mine. I did a whole talk on this at the an astronomy club meeting quite a while back, but I need to repeat that. But anyway, this is one of my things I like to do is by using Google Earth and an almanac, you can figure out where it's going to be at what time and make sure you're staying in the right place. And those are kind of fun to do too. And that was a 2015 eclipse, and so I wandered up and down the street until I got, put the moon in the right place,
This is just one of my early lunar eclipse shots that I did. It could have been the first lunar eclipse that I actually imaged back like in 2011, 12. And it's just multiple images then put in Photoshop and made it into a line. And then as I kept going a little bit more, I went down to Chile, and this is after our solar eclipse here. I think the next shot is this was the first solar eclipse shot that I got to take. And there's really no way to practice those until you get to see them. And so we were at my parents' farm, and we just got clouded out. And a friend of ours that was a club member, he moved to Maryland. He came back. He goes, I flew 1,800 miles to get back to Nebraska. I can't miss it. We hopped in the car, drove down the interstate as fast as we could, and people were passing us. And so we kind of got into the later stages of it. So that's why I don't have a full shot each way. But that was just with a little $80 telescope on a tripod, not tracked. Barely, the tripod could barely hold the setup. But so I mean, you can get good shots if you go back to the first one. Go forward. When I went down to Chile, then same telescope because I had to pack it in a suitcase and fly halfway around the world. But that is the same telescope setup and everything, little mini tripod. But when you kind of know what to expect, you can do that. And then the lunar eclipse over there, just the different phases that I took and then put it into Photoshop to make it a little more artistic. This was another partial solar eclipse, and that one was through a filter. It was up in the sky quite a bit, about 4 o'clock in the afternoon. The good thing with this one is we had sunspots, so you can actually focus on the sunspots. Otherwise, it's very hard to get a crisp, clear thing because all you have is a white circle on your image. This is what was I'm drawing a blank on what comet, it was the one in July.
Yeah, a year ago.
Yep. Neowise.
Neowise, yes.
And this was through a refractor that's not high-end by any means, but better than the little $80 cheap telescope that it had. Had it on this mount here, and we were out at Nebraska Star Party out in Valentine, and I think this is probably a 30-second to minute image, and then of course stacked and photoshopped, and but you can start to see the streams in the tail and everything, and the nucleus just lit up. Some of the reason some of the stars are purple is because of the telescope itself, the chromatic. Is it chromatic?
Yeah, the color fringing.
Yeah.
And yeah, actually in Photoshop and some other tools, you can get rid of that. It's there's a way you can get rid of most of it.
This was the Orion Nebula, heavily photoshopped, but just same thing, tracked on a very sturdy mount through a telescope, and taking multiple images to get the cores very blown out, but the outer clouds in the farther away from the center are very dim. So it's an easily seen target, but it's a very hard image to get because the core is so bright, it's so dim on the outer edges that you can't. It's kind of like the Jupiter and the moons. It's hard to get both of them in so that you can see it all in one image. Another, I think this is probably just a single or a very short multiple exposure. I think trying to think of what this one is. It's got to be something the summer, like Lagoon.
Could be, yeah, I don't do too much of that.
Lagoon Nebula.
Is that the rosette?
No, this would be out at the NSP. This is Sombrero Galaxy for Cinco de Mayo. So this was this is a very cropped image too, but it was through a very high-end refractor, just a regular DSLR that hasn't been modded or anything, deep sky stacker. Again, it's only 20, 30-second images, so 15 total minutes, so not very long at all. But thrown in the stacking program, you get some stuff like that. Black Eye Galaxy, again, only 15 minutes, but you can see the core and you can see the dust lanes and everything in there, and it's amazing what you can get in just a few minutes out there.
So yeah, this was done by Brett, and let's see, Dave Nisley helped with that too. So this is kind of a how-to.
So what we had it on this mount with another scope on top, and then it was just there's a mount for a camera, and so we just used a camera with a regular lens, no telescope, but we pointed at one part of the sky, and then Dave had his laser, and we were pointing, and I'm like, okay, it's in the middle of the frame, and he'd hold it, and then I'd move the telescope with the camera and everything just to another part to overlap, and we just gradually took photos all the way up the Milky Way.
So it's essentially the same as doing, terrestrial panorama stitching, and I use the same software that I use for that. It's just a little trickier because, like Brett was saying, you've got to build a two-dimensional pan, and keeping track of where you are and what comes next in that sequence is very difficult in the dark. So anyway, so this is the output from PT GUI, which is my favorite application for that. And you can see what parts of each image it used to build that. And so that's the raw image. And so that's 20,000 pixels across. And then this is after denoise and contrast adjustments. And then to get rid of the jagged edge, we did a little creative photoshopping and sent it off to the printer. So that printing that was about $800. There's some companies that will do, basically it's wallpaper and it's got an adhesive on it. So it ended up being 16,000 wide in the final version, and the PNG was 180 megabytes. So that's it. And again, you're welcome to come to a club meeting, and we don't have to join. Just come and visit, find out what it's like, and we'll get this posted online in the next week or so. So if you have any questions?
Yeah, essentially we wanted to get through this
Yes.
relatively quick so that we can do hands-on questions, anything like that. So
When you're imaging in real time, is there a way to verify that you've kind of got the shot that you want
yeah, so
without having to go to processing?
So what I usually do is when I set up a shot, I will crank the ISO up to absurd, like the highest ISO setting, to take a 10-second image, and it's gonna look terrible, but I can tell where I'm at. I can tell if I'm looking at the sombrero if it's in the shot. If it's not in the shot, I'm gonna have to reline, do something, but it only costs me 10 seconds. If you do a 3-minute, 4-minute shot, you're sitting there waiting and it's not in there. Well, not like 4 minutes is terrible, but when you want to get going and do stuff, every little second counts. So that's mainly how you do it, and it's usually you have to take some kind of image to verify.
It's also a good way to verify your focus.
Yes.
By cranking the ISO to look at your focus. Speaking of focus, that can be difficult because, especially if you're using a lens, it can be very close in between in focus and out of focus. And so focusing on something like the moon to try and get of course, shooting when the moon is up sometimes isn't the best for taking stars, or finding a street light that's way far away that you can focus on and then bring your focus up to the stars is a good way to do it.
Yeah, beware of that though. Street light is not at infinity, and it's amazing how the depth of field can really fool you. And so the best thing to do is find the brightest star or planet available and shoot that. And on this camera, I can do a live zoom into about 20x on the screen. And sometimes that isn't even enough and I get it done. I think I'm on focus, and I get it home, and it's little blobs. So it's just trial and error. And oftentimes what I'll do, and another factor that can come into this is as your optics cool, if you're out late at night and you start out, the camera is warming it up, but if it gets colder out, your focus can shift. So what I will do is try to bracket, and basically I'll do manual focus. I'll tweak it a little bit on either side of infinity just to make sure I've got 2 or 3 shots, and hopefully one of those is going to be sharp. So there's just all kinds of tricks you can use to.
When we were shooting that one, it was about every 5 shots, the camera would either turn or out of focus or whatever. And at Nebraska Sky, probably about 3, 4, 5 miles down the road, there's a radio tower or cell phone tower with blinking red light. And so that's what we actually focused on that about every 5 shots, because you could tell it was out of focus. And that was such a wide angle shot that we didn't really have a lot to go on. And so the red light was a pretty easily focused target that was miles away. And so although not truly affinity, at a wide field shot, it would, it'd be close enough.
And another topic we didn't touch on, excuse me, is dew. So if you're out there all night, generally cameras, if you're shooting with your camera, it's going to be generating enough heat to keep the lens warm so that you don't accumulate any dew, or it won't fog on you. But at telescopes, you need a dew shield sometimes. If you've got a big lens out there that is exposed to the sky, it's going to dew up on you. There are heaters, and now you can get little cheap USB heaters. It's just a little coil that you can Velcro around the camera lens, and that will keep it just warm enough so that you don't have to worry about that.
If you guys want to see some of the stuff like that I have, after this class is over, I can show you. I have it in a little box of goodies over there. But like I said, other questions?
Go ahead.
Well, I was wondering, so the pictures you had of the moon and the Capitol, so how did you take that to make the moon look so big?
It's all distance. You just gotta go forward or back until you
But is
frame
it a
it.
certain lens? Because is it like if you, like a telephoto
Well,
lens?
but yeah, if you are standing right next to the Capitol, no matter what you do, what lens you use, the moon is going to be small. You have to be, okay, that photo was taken from Sun Valley Boulevard, looking at with a telephoto at the moon to get the moon to be the right size, you know, at that distance. If the other photos of the lunar eclipse with the moon was smaller, those were taken from about a block away from the Capitol. And so you just kind of have to, you know, the telephoto is your feet. You need to find the right distance. So, and, you know, it's all trig. You know, you can figure out the angular diameter of the moon and then say, okay, well, I know the Capitol building is 360 feet tall. What is the angular distance there going to be? And then compare that to the moon and see how far away you need to be to match those up.
Also, if you're not really good with math,
Thank you.
there's websites.
Yeah, there's nice little there's nice little online calculators that I use to do the trig for me so I don't get it wrong.
There's also like, they have it calculated out where it's like ISS tracker, and it will actually tell you where to go to have the ISS go in front of the sun or the moon,
Yeah.
and tell you what time.
Yeah, I should have put in one of those shots.
There's also a website, as he was saying, that will tell you, okay, the moon's going to go through my shot, or the sun's going to go through my shot, if you don't want to do the manual computation.
Yeah, and there are some phone apps that will show you, you know, moon and sun rise azimuth, so you can figure out where on the horizon it's gonna come up.
And I think that was another thing too. I didn't know if there's any, if you guys do any instruction on that, like the photo pills or any of those apps. Because I know I've tried to use those and the math, it's confusing to me. So I didn't know if that was something you guys ever did.
I mean,
I'm sure
I use ISS tracker for that part.
Yeah.
I haven't done any
for the
moonrise
for the
things.
land-based stuff. There's a I'll have to put up the link to it. There's the Time and Date website that has a nice almanac in it for the moon and such. So I use that to get the azimuth for rise and then just track it and say, okay, when it's 10 degrees above the horizon, it's going to be at this azimuth. And then I go to Google Earth and use the in the app version, I use the measuring tool. And so you can put a point here and then drag the line and adjust the azimuth. So then you can say, okay, if I'm standing here, here's where I need to move to line it up. Yeah.
Yeah, because I know sometimes, so it's different, yeah, if you have, if you're in the mountains, like when the
Yes.
sun is rising and, you know, when it's gonna come up, or if you're like in the prairie. you know,
Yeah. And you know, the other way to just to try to gauge that is if you've got a day in advance or something, you know the location, you can go out and actually watch. Okay, where is the sun really rising? And then if you look on the chart and it says it's 113 degrees, then you've got a marker and you can find a feature on the landscape that's exactly where that's going to be, and then that gives you a reference point to work from.
It's transit-finder is the ISS one, so you can see. And you wouldn't even have to use it with camera. You can go out to the thing and just watch the ISS go in front of the moon. Or if you have solar eclipse glasses, you could watch it go across the sun.
The problem is that
It's about a second.
1 second is all you've got. And in fact, I've shot the moon, or the ISS going in front of the moon, and even at 60 frames per second, when I'm looking at it, even when I know it's in focus, and I'm watching it for it to happen, I seldom see it. It just zips by too fast. Then I bring the video back in and go frame by frame, and there it is. But it's really tough to get. And the sun is even worse, because if there's no sunspots, focusing on the edge of the rim of the sun is almost impossible. So every one that I've done has been a little blurry, faint shadow going across the sun.
Yeah, I think the only one time, it was right at about sunset, or the sun's about that far off the horizon. It was like 3 seconds, and you could actually see it go. But if it's up in the sky, I mean, again, it all math and trig and stuff, but that was very seldom do they last that long.
Yeah, back a couple of years ago, I drove all the way down to Cortland to catch one of them. It was right after sunrise. And, again, I had it, thought it was in focus. And I, even when I zoomed in, there was just this faint little shadow was all there was. It was so blurry that, but it was an interesting learning experience. I need to get back into that and do a few more and see if I can get it figured out.
One thing I found that works real well, at least for focus at night, is a Batnode mask.
Yeah.
And you can buy them, or if you know somebody that has a 3D printer, you can print them for different size lenses.
Yeah, and what that is a disc that you put in front of your lens that has a pattern of cutouts in it. And usually there's a grid of 3 that are oriented at 120 degrees. And they will basically it breaks the image up so that you'll see 3 of whatever you're looking at. So it has to be a bright object. And then you focus until they all come together into one, focused image. And then you take the filter off and you've got focus. You can even do it in the simplest version is just a disc that has 3 like 1-inch holes cut at 120 degree angles. And you'll see 3 copies of your image coming through that lens, and then you just line them up. And so if it's a bright enough object, it's a good way to focus.
I know the one we have out there, it's like diffraction spikes.
Yeah.
And so like it'll make an X, and then as you focus, there's one that goes through here, and you just line it up into the center. So it's a nice 3 intersection lines. And that's how I focus out at the observatory when I take images. I'll just throw that up there because you're right on.
And they make them for camera lenses. It's a Batinov mask.
It's like, how you spell it?
I don't know.
Bahtitov.
It's Russian.
BAHT.
I think there's an
IANOV.
Yeah, that's close.
focusing mask.
Yeah.
What about like minimum lens requirements? So like f value, focal distance, like what do you suggest if you're gonna do landscape?
Oh, I've used all kinds. I have one of my favorite lenses is like an f2, and it does a pretty good job. More is always better, but with as you get closer to f1.8, f1.4, the price just goes up and up.
Right.
So it's all.
I've shot with f7,
Yeah.
8.
Oh wow.
I mean,
Yeah.
you're gonna have a longer exposure, but you can do it.
Yeah, for
So I mean,
landscapes. Sorry, I didn't mean to interrupt
oh,
you.
go ahead.
Yeah, landscapes. I mean, prime lenses are great. You don't need the zooming capabilities, and they usually have a lower f value, so then you can take the image faster because your aperture is bigger, and so that way, hopefully, you don't see the star trails.
Yeah.
What about zoom lenses like you get with
Yeah, actually, yeah. I've been shooting Jupiter with my. I have it's 80 to 200 micro four thirds, which is the equivalent of like 160 to 400, and it's like a f4 to f8, and for planetary, it's good enough, And for doing deep sky, probably not. I mean, certainly not unless you put on a tripod and a guider. But I snap off pictures of the moon and Jupiter and Saturn all the time with that. And, it's not super high magnification, but it's not bad for a cheap zoom lens.
Ron, is PAC doing anything out here for the solar or lunar eclipse?
Yeah,
Okay.
we're gonna be open
So lunar eclipse on the
this Sunday night.
15th,
15th.
a week from
I guess
Sunday.
that's a week from this Sunday.
Yeah. But Branch Oak is also doing a thing. So there's plenty of ways. I don't know. Are you gonna the telescopes will be open?
We'll have the telescope set up, we're just hoping it'll be clear.
Yeah. We'll have
You
telescopes
won't-
and
You won't see the very beginning because it's like in the horizon behind our wall, but I think it starts at 8:30, right? So I think probably by 9 or a little after 9, it should be above the wall.
and then the total part of that's like 11 o'clock.
11
Something.
is totality. And then another 2.5 hours after that, it'll be over. So if you wanna stay up till 1:30, you can see the whole thing.
So and like at my observatory out of Branched Oak, we got a nice refractor that feels like a camera view. So if you want to bring your camera out there too, there'll be plenty of time to switch cameras and take photos if you want to try that too.
We've actually had a lot of people get some pretty nice pictures through our telescopes here with their
With the phones,
smartphone.
yeah.
They just hold it up to the eyepiece, move it around a little till they get a good picture and click.
The one thing we didn't mention with a camera, if you want to hook it up to a telescope, you need a T adapter. And the T adapter is just the ring, right? And then there's an extension tube.
Yeah.
Okay.
An iPhone or a phone adapter there.
Yeah, this is for a phone. There's a lot of different phone adapters that will just keep the
You don't have to hold it
yeah.
up, that will clamp it right behind your eyepiece, and then you don't have
But
to.
Yeah,
instead of the lens.
Yeah, and this, what you do is you get a ring that matches your mount, and then on the other side of that is a T adapter. It's basically a tube that matches the eyepiece, where the eyepiece goes on your telescope. And so then you just drop it in there like you would an eyepiece, and that's called prime focus. So you're not magnifying it, you're just using it as a big telephoto lens straight through. And then eyepiece projection is where you have a little tube that you put in the telescope, put your eyepiece inside of that tube, and then you focus it and use it like you normally would, but then the T adapter goes into that. So then you're doing what you're doing here, where you're using your camera lens, or well, the eyepiece as the lens to magnify.
Other questions? All right, well, thank you everyone for attending. Please consider the Prairie Astronomy Club if you're interested. Like he said, the meetings are open to the public as well. Otherwise, you get all those benefits. And like I said, if you have any questions, you can see all the stuff that I purchased and got started with. If you want to come up here, you can talk to Brett about his bigger mount, and you can talk to Mark about some of his experiences. So, thank you.
Thank you.
Thank you.